It is interesting to discover well-preserved residential-type electrical components on a vessel, especially considering the harsh marine environment. Finding a panel in good condition, along with functional ground fault circuit interrupters, is not typical. The longevity of these components might be attributed to infrequent use of the vessel or meticulous maintenance practices. A clean panel interior, particularly the breakers and bars, suggests proper initial wiring and limited exposure to heat or moisture. However, a comprehensive rewiring project is essential to ensure the vessel's long-term electrical safety and reliability. The presence of ground fault circuit interrupters, while functional, indicates an attempt to address potential electrical hazards. In a marine environment, ground fault circuit interrupters are particularly important due to the increased risk of electrical shock from water exposure. The electrical system of a vessel is complex and requires careful consideration of several factors, including 1. The type of vessel, 2. The intended use, 3. The applicable electrical codes and standards, and 4. The environmental conditions. The type of vessel is a significant factor in determining the appropriate electrical system design. For example, a small recreational boat will have different electrical requirements than a large commercial ship. The intended use of the vessel also influences the electrical system design. A vessel that is used for fishing will have different electrical needs than a vessel that is used for passenger transport. The applicable electrical codes and standards provide guidance on the safe and reliable installation of electrical systems on vessels. These codes and standards are developed by organizations such as the National Fire Protection Association, NFPA, and the American Boat and Yacht Council, ABIC. The environmental conditions in which the vessel operates also play a role in the electrical system design. Vessels that operate in saltwater environments require special corrosion-resistant materials and wiring methods. The main components of a vessel's electrical system typically include a power source, a distribution panel, wiring, lighting fixtures, and electrical equipment. The power source can be either shore power, a generator, or batteries. Shore power is typically used when the vessel is docked at a marina or other shore-based facility. Generators are used to provide power when shore power is not available. Batteries are used to store energy for starting the engine and for powering essential electrical equipment. The distribution panel is the central point for distributing electrical power throughout the vessel. It contains circuit breakers or fuses to protect the wiring and equipment from overloads and short circuits. Wiring is used to connect the various electrical components of the vessel. The wiring must be properly sized to carry the intended current and must be protected from physical damage and corrosion. Lighting fixtures are used to provide illumination throughout the vessel. The lighting fixtures must be suitable for the marine environment and must be installed in accordance with the applicable codes and standards. Electrical equipment includes a wide variety of devices such as pumps, motors, radios, and navigation equipment. The electrical equipment must be suitable for the marine environment and must be installed in accordance with the manufacturer's instructions and the applicable codes and standards. When designing and installing an electrical system on a vessel, it is important to follow these best practices. Firstly, consult with a qualified marine electrician. Secondly, use only marine-grade electrical components. Thirdly, properly size the wiring for the intended current. Fourthly, protect the wiring from physical damage and corrosion. Fifthly, install ground fault circuit interrupters in all circuits that serve outlets near water. Sixthly, label all wiring and equipment clearly. Seventhly, and regularly inspect and maintain the electrical system. Marine-grade electrical components are specifically designed for use in the harsh marine environment. These components are typically made of corrosion-resistant materials and are designed to withstand the effects of saltwater, vibration, and temperature extremes. Properly sizing the wiring is essential for ensuring the safe and reliable operation of the electrical system. The wiring must be able to carry the intended current without overheating or causing a voltage drop. Protecting the wiring from physical damage and corrosion is also important. The wiring should be routed in a way that minimizes exposure to physical damage and should be protected from corrosion by using appropriate wiring methods and materials. Ground fault circuit interrupters are an important safety device for electrical systems on vessels. Ground fault circuit interrupters detect small electrical leaks to ground and quickly shut off the power to prevent electrical shock. Labeling all wiring and equipment clearly makes it easier to troubleshoot and repair the electrical system. The label should identify the function of each wire and component. Regularly inspecting and maintaining the electrical system is essential for ensuring its safe and reliable operation. The inspection should include checking the wiring for damage, the connections for looseness, and the ground fault circuit interrupters for proper operation. The rewiring project should prioritize several key areas: 1. Proper wire sizing, 2. Corrosion protection, 3. Ground fault protection, and 4. Adherence to marine electrical codes. Proper wire sizing is crucial to prevent overheating and voltage drop, ensuring that electrical equipment receives the correct voltage and current. The American Boat and Yacht Council (ABIC) standards provide detailed guidelines for wire sizing based on the expected current draw and circuit length. Corrosion protection is essential in a marine environment due to the presence of salt water, which can accelerate corrosion of electrical components. Using marine-grade wiring, terminals, and connectors that are specifically designed to resist corrosion is crucial. Additionally, applying a corrosion-resistant coating to all electrical connections can further enhance protection. Ground fault protection is vital for preventing electrical shock hazards, especially near water. Ground fault circuit interrupters should be installed in all circuits that serve outlets or equipment near water sources, such as sinks, showers, and decks. Adherence to marine electrical codes and standards is paramount for ensuring the safety and compliance of the vessel's electrical system. The ABIC standards and the National Electrical Code (NEC) Article 555 provide comprehensive requirements for marine electrical installations. It is recommended to consult with a qualified marine electrician to ensure that the rewiring project meets all applicable codes and standards. During the rewiring process, it is important to thoroughly inspect all existing wiring and components for signs of damage or deterioration. Any damaged or corroded wiring or component should be replaced with new marine-grade equivalents. All electrical connections should be properly made and tightened to prevent loose connections, which can lead to overheating and electrical failures. The distribution panel should be inspected and cleaned to ensure that all circuit breakers and fuses are functioning properly. The panel should also be properly labeled to identify the circuits that each breaker or fuse protects. Once the rewiring is complete, the entire electrical system should be thoroughly tested to ensure that it is functioning properly and safely. This testing should include voltage and current measurements, insulation resistance tests, and ground fault circuit interrupter testing. The vessel's electrical system should be regularly inspected and maintained to ensure its continued safety and reliability. The inspection should include checking the wiring for damage, the connections for looseness, and the ground fault circuit interrupters for proper operation. Any necessary repairs or replacements should be made promptly. A well-maintained electrical system is essential for the safe and reliable operation of any vessel. By following these guidelines, you can ensure that your vessel's electrical system is properly designed, installed, and maintained. In addition to the points mentioned above, it's also important to consider the following aspects of marine electrical systems: 1. Bonding and grounding, 2. Overcurrent protection, 3. Voltage drop, 4. Battery management, and 5. Shore power connections. Bonding and grounding are essential for minimizing the risk of electrical shock and preventing galvanic corrosion. The bonding system connects all metallic parts of the vessel that are likely to become energized, such as the engine, metal hull fittings, and electrical equipment enclosures. The grounding system provides a path for fault current to return to the source, tripping the overcurrent protection device and energizing the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring and equipment from overloads and short circuits. These devices should be properly sized for the circuit they protect and should be of the marine-grade type. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause electrical equipment to malfunction or fail. To minimize voltage drop, it is important to use properly sized conductors and to keep wiring runs as short as possible. Battery management is crucial for maintaining the health and longevity of the vessel's batteries. Batteries should be properly charged and maintained to prevent sulfation and premature failure. A battery charger specifically designed for marine use should be used to charge the batteries. Shore power connections provide a convenient way to connect the vessel's electrical system to shore-based power sources. Shore power connections should be made using marine-grade shore power cords and connectors. It is important to ensure that the shore power voltage and frequency are compatible with the vessel's electrical system. When working on a vessel's electrical system, it is essential to follow all safety precautions to prevent electrical shock. Always disconnect the power source before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working on electrical systems, it is best to consult with a qualified marine electrician. The National Electrical Code (NEC) provides specific guidelines for electrical installations in marinas and boatyards in Article 555. It covers wiring methods, grounding, bonding, overcurrent protection, and other safety requirements to minimize electrical hazards in these environments. The code emphasizes the importance of ground fault protection, especially near docks and floating structures, to prevent electric shock drowning. Proper installation and maintenance of electrical systems in marinas and boatyards are crucial for ensuring the safety of boaters and preventing property damage. The rewiring project, therefore, involves a thorough understanding of marine electrical systems and adherence to relevant codes and standards. Selecting appropriate marine-grade components, ensuring proper wire sizing, implementing effective corrosion protection, and providing adequate ground fault protection are all essential aspects of a successful rewiring project. Regular inspection and maintenance are also necessary to maintain the integrity and safety of the vessel's electrical system over time. When performing electrical work on a vessel, always disconnect from shore power and any generators. Batteries should also be disconnected to prevent accidental energization of the system. Use a multimeter to verify that circuits are de-energized before working on them. Wear appropriate personal protective equipment, including insulated gloves and safety glasses. Work in a dry environment to minimize the risk of electric shock. Use only marine-grade electrical components that are designed for the harsh marine environment. These components are typically made of corrosion-resistant materials and are designed to withstand vibration and temperature extremes. Choose the correct wire size for the intended current draw. Undersized wires can overheat and cause a fire. Consult the ABIC standards for wire sizing guidelines. Use proper wiring techniques to ensure secure and reliable connections. Crimp connectors should be used for making wire terminations. Soldering is generally not recommended for marine electrical connections because the solder can corrode over time. Protect wiring from physical damage by routing it through conduit or using chafing gear. Secure wiring runs with cable ties or clamps to prevent movement and vibration. Properly ground all metallic parts of the electrical system to minimize the risk of electric shock. The grounding system should be connected to a common ground point. Install ground fault circuit interrupters in all circuits that serve outlets near water or in areas where people are likely to be wet. Test ground fault circuit interrupters regularly to ensure that they are functioning properly. Label all wiring and equipment clearly to make it easier to troubleshoot and repair the electrical system. Keep wiring diagrams and maintenance records readily available. Inspect the electrical system regularly for signs of damage or corrosion. Replace any damaged or corroded components immediately. Have the electrical system inspected by a qualified marine electrician periodically to ensure that it is in good working order. The importance of proper documentation cannot be overstated. Maintain detailed records of all electrical work performed on the vessel, including wiring diagrams, component specifications, and test results. This documentation will be invaluable for future troubleshooting and maintenance. Consider creating a comprehensive electrical system plan that outlines the layout of the wiring, the location of components, and the specifications for each circuit. This plan will serve as a roadmap for future electrical work and will help to ensure that the system is properly maintained. In addition to the technical aspects of marine electrical systems, it is also important to be aware of the relevant regulations and standards. The EBIC standards are widely recognized as the industry standard for marine electrical installations. Compliance with these standards is essential for ensuring the safety and reliability of the vessel's electrical system. The National Electrical Code, NEC, also contains provisions that apply to marine electrical systems. Consult with a qualified marine electrician to ensure that the vessel's electrical system complies with all applicable regulations and standards. Rewiring a vessel's electrical system is a complex and challenging task. However, by following these guidelines and consulting with qualified professionals, you can ensure that the project is completed safely and successfully. A well-maintained electrical system is essential for the safe and enjoyable operation of any vessel.